We are familiar with many types of file formats: CSV, Avro, text-based, Excel. Those are some of the file formats we are familiar with. Here we are going to learn about Parquet, which is another type of file format. Two ways mostly we'll store data in a file. One is the row-based, the other one is column-based. We are more familiar with the row-based file formats because we have seen CSVs. In CSV, all the attributes of an entity will be written first, then we'll write the next entity, one after the other. Here you can see the row-based file representation of a person entity. Person has name, occupation, age, and city. So each person's name, occupation, age, and city will be written first, then the next person's details. Here Jane's details will be written first, then the Raj, James, etc. From this representation itself, we can understand that if we have to write so many or millions of entities, then this representation will help us to write it faster because all the details of one entity will be written, then the next entity will be written at the end of the file, then next entity, and we will be appending the entities at the end of the file. So if we have a write indency operation, then row-based file format is the best option for us. Next one is the column-based file format or columnar file format. It's just opposite to the row-based file format. If you want to see the column-based file format representation, you just turn this image into 90 degrees. So here columns will become rows and rows will become columns. That means all the values of one column will be written first, then next column's details will be written, then the next one. Here we know that it is not that great for write indency operations because we'll have to get all the entities first, then all the values of name we have to write first, then the occupation, then the age and city. But if we have to read, we may not need all the columns. Maybe we need to read some of the columns as per some conditions. Think about a scenario where we want to get all the people whose age is greater than 25. In that case, the parser will directly go to the age to offset and read all the values in the age and compare the value with 25. Any of the value which is more than 25, for that it will go to name and read the value. That way, it need not read the whole file into memory. Only a few columns it has to bring it into memory and put the condition. Think about the same thing if you want to do in a row-based file format. In that case, the parser has to go through each of the row and compare with the condition, and it has to scan the whole file. That is avoided in the case of columnar file format. So, columnar file format is the best option for a read indency operation. Now let us look into the Parquet file format. Parquet is a columnar file format, but it is a bit different from the columnar file format. It is somewhat like a hybrid of columnar and the row-based file format. Here we have a logical partition of row groups. Row group is nothing but values of a limited number of rows are stored together. Here you can see that the values of row 1, row 2, row 3 and row 4 are stored as part of row group 1. Each row will have all the columns. That means row 1 will have its name, occupation, age and city. Same way row 2, row 3 and row 4. Again, the data in each of the column is grouped into column chunks. Each row group will have exactly one column chunk for each of the attributes or each of the columns. So you can see that for name there is a column chunk, occupation, age and city have their own column chunks. Each column chunk is divided into multiple pages as per the page size. So this is the way data is stored in Parquet file format. So we can see that first data for the row group will be stored. That means Jane, Raj, James, train will be stored. After that engineer, test, engineer, architect for the occupation will be stored. Then the age 45, 35, 22, 49 will be stored. Then New York, Bangalore, London, SFO will be stored. After that row group 2 data will be stored. Same way, rest of the row groups will be stored. Parquet stores three types of metadata. One is the file metadata. It will have version, schema, etc. Then for each column chunk, there will be a column metadata that will have which all encodings used for that column chunk, then the path in schema, number of values in that column chunk, etc. Then the page metadata that will have data page header, index page header, dictionary page header, etc. So Parquet uses different types of encoding to reduce the size of the data that is stored. The first type of encoding is plain encoding. Here boolean will be represented as bit packed. In32 is represented as 4 bytes, etc. Here not much compression happens to the data. Next type of encoding is dictionary based encoding or dictionary encoding. We know that in dictionary one word will be stored only once and we will use page number and line number to find each of the words. So that means we will go to the index. Same logic is applied here. Here you can see that the column values are Bangalore, Bangalore, Mumbai, Bangalore, New York, New York, Mumbai. That means so many strings are repeated here. This is the city value for a person. If you are representing it in a dictionary, then it will have only three values: Bangalore, Mumbai, and New York. In the column values, we'll show the index. That means instead of the column value Bangalore, we'll store the index of Bangalore in the dictionary. That means here it is 1. Then next value is also 1. Then the next value is Mumbai. So the index is 2, 1, 3, 3, 2. That way. We can see that the size of the data is reduced here. Strings are not repeated here, but the pointers are added to the column values. But here also there is a chance that dictionary value can go more than the actual column values. Consider a scenario that these values are not repeating or very less repetition in the column values. In that case, we'll have to store the dictionary values plus the indexes. So the Parquet library, if it finds that the dictionary value is more than the actual column values, it will fall back to the plain encoding. Another type of encoding is run length encoding. Here we can see that a number of values are repeated here. Here 5, 3, 2 is repeated multiple times, 10 is repeated multiple times, and 5 is repeated multiple times. Instead of storing all these repeated values, we will apply the run length encoding. In run length encoding, we will be storing each value how many times it repeated. Here it is representing that 5 is available once, 3 is available once, 2 is available 5 times, 10 is available 6 times, and 5 is available 7 times. So only that representation will be stored in run length encoding. That way repetition will be removed and data size will be reduced. Another encoding is bit packed encoding. Here we can see that column values are 0, 1, 2, 3, 4, 5, 6 and 7. There are 8 integers here. To represent one integer, we need minimum 4 bytes. So here we need minimum 32 bytes to store all these 8 values. To avoid that, in bit packed encoding, what we do is we'll take the hash value and we'll see how many bits are required to represent the hash value. Here the hash value is 7 and we need only 3 bits to represent 7. So we know that rest of the values are smaller than 7 and it can be represented with 3 bits. So all the value will be represented with 3 bits. So we can represent all these 8 values with 24 bits instead of 32 bytes. That way the data size can be reduced. Another encoding is delta encoding. In some cases this bit packed encoding will not do much of a conversion. Suppose we have huge integer values and it might need 32 bits to represent each of the values. In that case, bit packed encoding will not do much conversion. So we'll apply the delta encoding. In delta encoding, we'll store only the delta between the adjacent values instead of the actual value. In this example, you can see that column values are 7, 5, 6, 8 and 12. Instead of storing all these values, we'll store the first value, that's 7. Then we'll store the difference or the delta between the adjacent values, that is 5 minus 7 minus 2, 6 minus 5 1, 8 minus 6, 2, and 12 minus 8, that is 4. So we'll be storing minus 2, 1, 2, and 4. We can easily find the value by adding it with the start value. 7 plus minus 2, 5. 5 plus 1, 6. Then 6 plus 2, 8. Then 8 plus 4, 12. That way we can find the values. But here we can see that there are negative values. To avoid that negative value, we'll take the lowest value and subtract it from all the values. Here the smallest value is minus 2. Minus 2 will be subtracted from each of the value. That means minus 2 minus minus 2, 0. 1 minus minus 2, 3. 2 minus minus 2, 4. 4 minus minus 2, 6. So we'll be storing 0, 3, 4 and 6. Now we can add the bit packed encoding. So 6 can be represented with 3 bits and all the other values will be, all the other values can be represented with 3 bits itself. So we have 4 values to be stored. So total bits that is required is 4 into 3, 12 bits plus the start value. So far we have seen how the Parquet file is stored and what are the encodings. Let us see what's the benefit of using Parquet file format. We know that metadata is stored with column chunk, page and file. In column chunk, there are 2 more values stored. Those are the minimum value in that column chunk and the maximum value in that column chunk. In this example, we can see that row group 1 age is having minimum value as the 22 and maximum value as 49. So let us consider an example. If we want to select name from this dataset where age is greater than 46. To get the value for this SQL query, what the Parquet parser will do is, it will go to each of the row group. It will go to the first row group, then it will go to the age column chunk, then it will take the maximum value and compare with 46. Here the maximum value is 49 and we know that 49 is greater than 46. That means this row group is having some person whose age is more than 46. So it will get the column chunk for age and sequentially parse and check each of the values. Here it will find that 49 is there and it will go to the name column chunk and get the name for that person. Here it is Shane. Next it will go to the row group 2. There the maximum value is 45. That means it is less than 46. So it will just keep that row group. Next is the row group 3. Their min-max value is 22. It simply skips that row group as well. So it need not parse all the data in that file. Depending on the metadata available, it can skip some of the row groups and the querying will be faster. That's the benefit of using a Parquet file. In the next video, we will see how to read and write Parquet file using Java.